In this video, we will solve a numerical problem based on boundary value problems to solve for Laplace equation. Here, this question is given with angle phi. Thereby, we will be using this in cylindrical system. So, semi-infinite conducting planes at phi 0 and phi pi by 6 are separated by infinitesimal insulating gap. And the two planes are at two different potentials. One is at 0 volts and the other is at 100 volts. We are asked to calculate voltage and electric field intensity in the region between the plates. So let us draw graphically this semi-infinite conducting planes. So one plane is at angle of phi equals to 0 and another plane of angle phi equals to pi by 6. So these are semi-infinite conducting planes. Also, it says infinitesimal gap is there. Infinitesimal insulating gap is there between the two plates. Now, at this plate, phi equals to 0, potential V is 0. This is grounded. And another plate here, potential V is at 100 volts. So between these two plates, we have to find potential, which is a function of phi, and electric field intensity vector. So let us write the boundary conditions first. First boundary condition is at angle phi equals to 0, potential V is 0 volts. And the second boundary condition is at angle phi equal to pi by 6, potential V is 100 volts. Here, we have already been given with angle in radians. So we have to use angle in radians for substituting and solving this problem. So starting with the Laplace equation, we know Laplace equation is del square V equals to 0. Now we will be writing the Laplace equation in cylindrical system, which is 1 by rho, dou by dou rho of rho, dou V by dou rho, then plus 1 by rho square, dou square V by dou phi square, plus dou square V by dou Z square equals to 0. Now, when we consider here in this case, potential is a function of angle phi. So differentiation with respect to rho and Z will be made 0. Only this term is left. So we will be getting 1 by rho square, d square V by d phi square equals to 0. This rho multiplying with 0 in the right hand side will give d square V by d phi square equals to 0. Now integrating with respect to phi, will give dv by d phi equals to integration of 0 is 0 plus constant c1. Now one more time integration with respect to phi will give, so integrating with respect to phi one more time will give c1 phi plus c2. Now this angle phi should be used in radians. We already have the boundary conditions. We can take these boundary conditions, apply the boundary conditions and find constant C1 and C2. After getting the constant C1 and C2, we can find the expression for electric field intensity as well. So applying the first boundary condition, we will get 0 equals to C1 into 0 plus C2. This provides C1 0. Now second boundary condition, if you apply, 100 equals C1 into pi by 6 plus C2. C2 has already been made 0 because of the first boundary condition. Now when we take this, C1 will be 600 by pi. So substituting these two, C1 and C2 into the voltage expression, we will get V, which is a function of phi. So V, which is a function of phi, will be equal to 600 by pi phi plus C2 is 0. So this is the voltage, which is a function of phi. Now we should find electric field intensity. We know electric field intensity is minus del V, that is negative gradient of potential. So gradient formula in cylindrical system should be written dou V by dou rho A rho cap plus 1 by rho dou V by dou phi A phi cap plus dou V by dou Z A Z cap. Here, the potential function is having only variable phi. Thereby, we will be taking the differentiation with respect to rho 0 and Z 0. since V is a function of only phi. Now take this, differentiate with respect to phi, and write the answer for potential, electric field intensity in terms of negative gradient of potential, minus 1 by rho. Now dou V by dou phi will be 600 by pi, and the direction vector is A phi cap. So this is the expression for electric field intensity. We must give the units for both electric field intensity and potential. Electric field intensity has the unit volt per meter. Potential function has the unit volt. Now these two are the required things asked in the question. I hope you understood this problem. Thanks for watching the video.